Hello, Mr. Cam, and welcome to our 3 videos on random sort, bubble sort, and merge sort. To start, we're going to look at random sort, sometimes called monkey sort. Random sort uses a simple but time-intensive way of sorting. It essentially randomizes the cards, throwing them into a hat, and then it picks out the cards in a random order. It then checks to see if the cards are properly sorted. It will almost never be sorted on the first try, especially when using a larger number of cards. In this case, we are using 8 cards. The sorting algorithm will continue until it is properly sorted. The approximate amount of times it will take to sort is calculated by taking the factorial of the number. In this case, 8 factorial, which is 40,320. Random sort, unlike other algorithms, is uncapped. This means it could successfully sort it on the first try, or it could take even more attempts than 40,320. The number's factorial is just a good estimate. This is unlike many other sorting algorithms, which do have a capped amount of steps it could possibly take in order to properly sort the items. After a random amount of steps, depending on how long the algorithm takes to sort, it will fully sort the items so they go from lowest to highest. Here is how the code of random sort works. Up here, it starts to randomly sort the given list. This creates a new boolean, a true or false condition, and it indicates whether the list is sorted or not. This while statement says that while the list is not sorted, continue shuffling until the sorted list is discovered. This here sets the list to be sorted once it's successful. This if statement down here is very important. This is essentially saying that if the length of our list is more than 1, meaning if there is more than one object or item that needs to be sorted, then for every character from 0, the first item, to the length of the list, which is of course the max number, if a number is greater than the number after it, then the list hasn't been sorted. This is because we want the list to be sorted left to right, lowest to highest. So that means that if a number on the left is greater than a number on the right, that means that the list hasn't properly been sorted. And that's how the code works. Random sorts, pros and cons, are straightforward. The code is simple to understand and not too difficult to create. However, it is very slow, and if you need to sort something like billions of numbers, it will take a very long time. Using 8 numbers, it already takes approximately 40,320 steps. So if you were to sort higher numbers, the number of possible steps rises exponentially. In conclusion, random sort is useful in particular situations and has its place among the sorting algorithms. However, it is not nearly as efficient as many other sorting algorithms, which we'll get to in the next couple of videos.